All right, let's get this session started. Thanks everyone for coming and hanging out with us today. First, let me to kind of introduce myself. My name is Lorin Crawford. I'm a principal researcher at Microsoft Research New England and an associate professor in the Department of Biostatistics at Brown University. I was also fortunate enough to be a member of the great 2023 class of the COPSS Leadership Academy. As a little bit of a background, COPSS is a committee of presidents of statistical societies. COPSS is made up of various statistical societies, including the ASA, ENAR, WNAR, IMS, and the Statistical Society of Canada, along with many friends and societies across the globe. COPSS bestows many awards each year, including the new COPSS Leadership Academy, recently renamed to the COPSS Emerging Leader Award. The purpose of this award is to recognize early career statistical scientists who show evidence and potential for leadership. It also provides a mechanism for us to share our vision of leadership with the field. From this emerges this webinar series, which is co-organized by COPSS and our wonderful partners at the National Institute of Statistical Sciences. These leadership webinars are an opportunity to feature leaders throughout the discipline, invite them to tell their leadership stories and share their insights. There's an opportunity to celebrate statisticians and data scientists who have achieved many great things and who have inspired many others along the way. Today's topic is leadership at the intersection of technology, tech, and academia. In our profession, many of us feel like we're faced with this metaphorical kind of fork in the road where we feel like we must choose between a career in academia or one in industry. But as technology continues to advance, the one strong line separating between these two sectors continues to blur. So much so that there have been an emergence of careers that almost sit like academia or industry adjacent, basically jobs with roles that have characteristics pulling from both spaces. We're fortunate today to have two of our own here with us. And so I'll go ahead and introduce both of these incredible speakers. One of them is a little bit late and she'll be joining us soon, but we're fortunate to be joined here by Natesh Pillai. Natesh is a distinguished engineer in responsible AI at LinkedIn, also professor in the Department of Statistics at Harvard University. Natesh has done incredible things in his career thus far, as elected fellow of the ISI, Young Statistical Scientist Award in Statistical Theory in 2018 by the International Indian Statistical Association, editorial board of JASA, JRSSB, Journal on Mathematics and Data Science, as well as the Harvard Data Science Review. And previously, before his current position, was also chief scientist at Correlation One from 2019 to 2021, and an Amazon Scholar 2021 to 2023. And our other speaker who will be joining us soon is esteemed Dr. Barbara Engelhardt. Barbara's a senior investigator at the Gladstone Institute of Data Science and Biotechnology, also a professor in the Department of Biomedical Data Science at Stanford University, was previously a professor at Duke and Princeton. Barbara's also won an incredible amount of awards and deservingly so. She was the Overton Prize winner from the International Society of Computational Biology, an Alfred P. Sloan Research Fellow, but also has done a lot of things in industry, including being an advisory board member for many different companies, and has had grants funded by industry-based places, including Silicon Valley Community Foundation, and works that have been co-supported by places like the Chan Zuckerberg Initiative. The structure of today's event will be as follows. So each panelist will have about 10 minutes to talk about their leadership journey, and then I have some prepared questions for them. And then finally, we'll open up the floor to the audience. So, I'll turn it over to Natesh. Natesh, will you mind telling us a little bit about your story and your journey to where you are today?
Yeah, first of all, Lorin, thank you for organizing this, and thanks to the COPSS organization for putting this together. As growing up in the statistics circles, this is a great organization, and I know we're doing many good things, so it's a pleasure to come and speak here. Maybe a little bit of background. I went to graduate school at Duke, did a postdoc at Warwick, and then came to Harvard maybe about 2010. During that time, I was mostly interested in theoretical stuff, although I got the training I got throughout was just grounded in applications. Before that, I was a civil engineer. I changed careers. And so that always had that engineering mentality, that had instilled this engineering mentality in me and how to think about problems, etc., even though I was working on pretty mathematical stuff. But then the evolution was natural, because as many of you know, our field really comes alive when coupled with applications and seeing the challenge in applications. And I must say, being at Harvard really helped a lot, because many of my colleagues sort of invented foundational fields in our discipline. So it was good to be. So while I was ensconced in, I was instilled in those way of thinking, the industry happened naturally. And I was slowly also maturing as a researcher, going from purely theoretical problems to developing methodology for scientific applications. I've worked across climate science, biology, spatial statistics, and across all of these disciplines, the problems started to really talk to me. And also, while I was working on it, I realized that while our training, while our discipline has amazing people, we do still lack some of the basic training in the applied computational side that some of our students could use, especially when it comes to industry. So my first foray was a chief scientist of Correlation One, where we developed a curriculum to teach data science to people across industry, across various groups. And I went to Colombia, South America, several times to teach their people. That was fun. Taught thousands of people, especially, and also I switched from R to Python, by the way, and that is an important transition point. Now I do use R, but I don't really get into the debate of R versus Python, but that was a distinct change, I remember. But that was in also teaching myself the skill set throughout, in needing to really understand where the technology is, what are the what is it that people are doing that you may not really see in an academic environment. But that was still on the teaching side. We're teaching people how to use these tools. But I also wanted to, one of the reasons why I always done this is to have real credibility when I'm going and talking in front of students, to say, I've done this, and this is what happens in industry. So Amazon was a natural next step, where I wanted to not just be involved in teaching, but in an actual industry research environment. And there, with my friend Eric Laber, who's a professor at Duke, we sort of ran a reinforcement learning lab, so to speak, where we, again, using these ideas of adaptive clinical trials, etc., which statisticians know quite a lot about, bring those into industry problems and think about how do you use adaptive learning in very difficult problems. And that the mandate was also that we could just, there was a pan-Amazon-wide mandate. We could just really go talk to any team that we think we could make a difference to and solve that problem. So that was fun as well. And then okay, well then even that was still I feel part-time, even though my summers were fully consumed. But then I realized, well, I still want a full corporate immersion. So this opportunity came at LinkedIn, and I thought, well, equity has always been very close to my heart, and also that I think LinkedIn is one of the industry leaders of this responsible AI, where many companies are not even, these kind of problems are not even in their radar, versus LinkedIn, I would say, is quite far advanced. So it's good to be in the trenches to really work and set up the foundations. And it's very interesting, because it's really not just only statistical work, but also how it interacts with policy, law, people, and so that's it's a wonderful, beautiful challenge. So I'll just stop there.
If I could ask like one follow-up question, just for the viewers and also for my own knowledge, can you give us like maybe like a minute summary of what it means to be a distinguished engineer, like what that title is?
Yeah, well, I mean, I don't care too much about the title. I think it's the sort of the highest position in an IC, individual contributor role, and typically people have, when they get to senior, they have two choices. They can still remain an individual contributor, or they can go be a manager or VP and all of that. I still choose to be a scientist, and I want to be able to think about science, and so I chose to stay in this role as senior IC individual contributor.
Awesome. And now we have the pleasure of being joined with Barbara. Barbara, how are you doing? Good?
I'm good. How are you?
Good. So we're just going over your individual leadership journeys. Would you mind sharing yours and giving us a little bit of insight about the path that you took to where you are now, and also maybe sharing with people what is Gladstone as well.
Yeah, absolutely. Thanks. And first of all, apologies for being late. It's part of a commute in the Bay Area, I guess, that it's unreliably slipped sometimes. Okay, so my journey. First of all, thanks, Natesh. That was awesome. And I loved hearing about what you've been through. So I grew up in New York City. My dad was a professor, but then actually left for industry when I was pretty young. So he was at Columbia. So I grew up in the Upper West Side. And, he left right before tenure. So tenure was always this thing that was like, maybe I just can't ever do that, right? Even though being a professor was something in my mind, it was like tenure is sort of impossible. Why would I even bother? So, I went to Stanford for undergrad, which was lovely. I volunteered for accessibility, like robotic accessibility, when I was a sophomore, which really affected me. I worked with a paraplegic I programmed a headband so he could play Pong, and worked with a woman who was deaf, thinking about accessibility tools for her, and also there was a philosopher who ran it at the time, John Perry, who was just wonderful, and really started thinking about what it means to not have all the abilities that we take for granted, right? And how to use technology to sort of give people those abilities. I didn't think of that as a career, but maybe we could argue that could have been a career for me too. So the next 2 years I worked for Ames, NASA, in doing robotics, basically again, which is kind of strange because I ended up more in statistics. I did a co-term there, got a master's, and then actually went full-time working for Jet Propulsion Laboratories. And there I was doing planning and scheduling. This is very government. And remember, I graduated in like 1998, 99. Literally every single one of my friends and colleagues went to Google or some version of that, Yahoo, or whatever. And I was like, no, I'm going to go work for government. That sounds great to me, which was a terrible idea in retrospect, but financially, I guess. But there I was at NASA, and that was actually lovely. I got to work with some amazing planning and scheduling people, but do some really cool stuff. Thinking about decision making, we were doing planning and scheduling, but I started thinking about that from the statistical perspective, and thinking about automated sort of stopping based on Hofting inequality and other sort of ideas that I had never really had access to before. At some point, I realized I was not going to stay there because everyone in my group had a PhD. So I started applying around, and the most awesome school seemed to be Berkeley. So I went to Berkeley and in computer science, or EECS. But if anyone knows Mike Jordan, he basically says, okay, go over to Evans Hall where the stats department is, and don't come back until you know stats. So it was lovely. And I got to take some of the greatest classes ever. I could list all the amazing people, but Bin Yu is one that stands out. She just taught one of the greatest information theory and statistics classes I've ever taken, or one of the greatest classes I've ever taken. Let's see, during that time, a lot of things happened, I guess. 9/11 happened, which was kind of overwhelming, where you have to sort of think about what's next. I did a research internship at Google, in Google Research. And it was really fun. I got to implement basically a hierarchical Dirichlet process, give or take, to think about topics and web pages. And it ended up being super fun. And the data there are obviously amazing, were amazing at the time, but it was just incredible to see everything that was going on. But it was my first real taste of industry, I think. And it was very different than I'd expected. Even if it was Google research, it was still very industry. It was sort of end focus. Every week I would meet with my mentor, who was amazing. But he would sort of evaluate how my progress was going, and it was kind of goofy because anyone in research knows that progress is always peristaltic in some sense in research. But it was great. I had a wonderful time. Graduating from Berkeley, I actually went two paths. I actually I did a full academic search, and I did a full postdoc search. And I ended up taking a job at 23andMe, which at that point was like 7 people. So it was teeny tiny. So I got to think, I mean, at first, I went there and they were sort of like, okay, just build the software infrastructure. But there were so many statistical questions, even with the small number of genomes that we had at that moment. That was the thing I was drawn to. So it was really amazing to be able to, 1,000 genomes was more than anyone else had at that point. So it was really a real pleasure to mess around with those as much as you possibly could. And we did. I did that for a year. And then realized I needed to go back to academia again. I wasn't quite done there. 23andMe was great. Don't get me wrong, but it was just, I feel like there's, as my PhD advisor says, there's this sort of rebellious teenager in me, always, where, they say, do this thing next, build this thing or whatever. And I won't because I don't want to. I want to build something else, something that's fun, something that I think is going to be better in the long term. But, my manager just doesn't see it yet. So that was always a problem with me in industry, quite honestly. It's not everyone's problem. It's very personal. So yeah, and then I went to do a postdoc at University of Chicago, took my first professor position at Duke, learned to be a real Bayesian there, which was super fun. And that is one of my favorite stats departments, as Lorin and Natesh can probably possibly agree to. It was amazing. Then ended up moving a couple of years later to Princeton. Doesn't have a stats department, has Orphe, I guess, but there are statisticians everywhere. In fact, some of the social scientists actually were my funnest collaborators there. But yeah, it felt very, very different to be in a CS department again and doing what I'm doing, which is, building essentially biostatistics for electronic healthcare records, for genomic data, in the context of, this very, at this point, heavy-handed deep learning field. So that always felt kind of weird. But I did, and as a rebellious teenager, I expanded what I was thinking about and didn't just focus on genomes, but started focusing on electronic healthcare records, started focusing on decision making and reinforcement learning, and it became really exciting and fun, and I could pivot whenever I needed to. At some point, I got tenure, and I went off and did a sabbatical at Genomics PLC, which was just awesome. Am I taking too long? I'm just telling a whole story.
No, go for it. Right.
Okay. Genomics PLC, which felt actually, interestingly, a lot like this sort of nascent 23andMe experience, although maybe twice as many employees at that moment. It felt like the stats department at Oxford, right? It was just amazing with Gil McVean and all these people that are just unbelievably brilliant statisticians. Peter Donnelly, obviously, just incredible people. But at the end of the day, they're building a product. So I loved being there. I loved learning about polygenic risk scores. I loved building my own polygenic risk scores. I mean, that was just a treasure. But when it came to thinking about could I do this forever? The answer is no, I don't think I could. Again, it's my issue, not everyone's issue. But there was amazing power in being able to just press a few buttons and have a Manhattan plot show up with all the whatever phenotype I'm thinking about hits. But but it just it wasn't what I wanted to do. I wanted to build my own methods to do that. So and that was also during COVID. So I ended up being remote for part of that, which was pretty rough. I'd rather have been there. But it ended up like getting up really like 8 a.m. 3 a.m. every day to go to work, in the UK, which was kind of rough for a while. And then finally, I sort of realized it was time to move on from Princeton. Princeton's lovely. It doesn't have a med school. It's very, it feels very theoretical a lot of the time. So again, this is my issue. I tend to be a traveler, as it were. So I ended up getting 2 amazing offers, and the one I ended up at is here at Gladstone and Stanford. So at Stanford, I'm in this department called Biomedical Data Science. It's wonderful. I mean, half of it's, the statisticians that you all know and love from Stanford. So Trevor Hasty, Rob Tibshirani, Chiara Sabati, they're absolutely amazing. And the other half is sort of up and coming computer scientists, machine learnists, I would say, doing really cool work. Like Serena, and it's been amazing to be there and to work with this new group. But I'll say, Stanford's a university like everyone else, and not a very big one, actually. So I end up hanging out with John Ducci. We organized a reading group, and I'm spending a lot of time with people in computer science. And long story short, it feels like the experience I want. I'm excited to stay at Stanford for forever and never want to leave. I started going again to, stats talks, which sounds really weird because I've been, an academic forever, but I haven't really gone to stats talks since I was at Duke. And it's wonderful, and things have changed a lot, and I love it. And so, I'm back in my sort of happy place. But also the opportunities there, needless to say, are incredible. Genomics is amazing, and people are really focused on technology development, which really didn't happen that much at Princeton again. And being able to do the back end of the technology development, which is understand the biases, build the statistics, has been amazing. Gladstone is, I would say, sort of like the Broad, but California style. It's much smaller. I would argue it's probably the place with the most heart that I've ever worked before. They really walk the walk in a way that I've never seen an institute do that before, in terms of hiring amazing people, kind people, and really focusing excellent science in order to cure disease. It's a very single-minded focus. I've, again, never really worked at a place with a single-minded focus like that in academia. But it's just a real pleasure, a real treat. They let us do whatever we need to do to be able to solve the problems, and that means I get to go absolutely crazy in terms of the ideas, high risk, high reward projects all over the place that have turned out really well so far, knock on wood. But like thinking about reinforcement learning, inverse reinforcement learning for understanding the behavior of CAR T cells using these live imaging experiments, which is just phenomenally exciting. And, I'm getting chills just thinking about it, and showing these CAR T cell behavior patterns to cancer researchers, and they start going off and thinking about how to design different behaviors. And it's a real sort of hand-in-hand collaboration that I've never had anywhere else, which is very exciting. So I have sort of a 50%, I'm a professor at Stanford, 50% I'm a researcher at Gladstone, and it's wonderful. I'm exactly where I want to be, and I feel like the opportunities are amazing. Yeah, I think that's it.
That's amazing. I'm going to open up the floor for questions. So if anyone has questions, please put them in the chat. I'll monitor the chat. I do have prepared questions for you too, if that's okay. So one cool thing I noticed about both of your stories is this like moving kind of back and forth almost seamlessly between academia and industry. It may not be seamless, but that's how it was portrayed, at least to me. What are some pros and cons that you both see from being solely in one of those two spaces? Like either from a research impact perspective or even just from a career perspective. I don't know, Natesh, if you have thoughts on that.
Yeah, I can start. Nice to see you, Barbara. I won't generalize, but I will tell you my experiences. So, for example, at Amazon, I could just spin up an AWS machine, a GPU, several cores, if I want to run an RL algorithm, if I want to. And if we need, and some of these algorithms to really make it work in real world takes real engineering support too, and not just and so that if the problem needed it and the teams have resources, we will have access to that, which is sort of unheard of. It's not possible to imagine that in academia. I can't really spin up a few cores. Even in my university, sometimes I have to wait for the cluster access, and then randomly fails, no accountability, and all of that. I mean, that's part of life, and I think the universities are changing, but that's still it's motion activated. I still haven't figured out how to. I'll speak without the light. So I think that's and it's not a. I don't want to criticize academic institutions for that. I'm just saying that's a state of affairs. The academic world, on the other hand, of course, offers wonderful opportunities. First is the students, which I'm really solely in the business for, so to speak, and also wonderful colleagues who really pursue the life of mind. But also that especially having seen in industry, the ability to pursue questions for the sake of it is still, I still think there is some value in it, and that all researchers should at least spend some part of their time in pursuing that, and not because of, especially when you get into a little bit more senior levels, just pursue a question for its sake. Maybe it's interest to you and you care, and the society trusts in your taste for you to get here. And industry, you don't often have that possibility. The other thing is that in industry, sometimes the sophisticated methods just do not work, or will not be implemented in any real time, in any real time frame. So many of the methods that you may come up with in academic point of view may not just fly in industry, and therefore, and that's a different interesting challenge, but it is a challenge too. So you can't just really be wild in developing methods. You really have to pay deference to what the infrastructure that is available to you. So there is lots of pros and cons, and that's why I truly believe the best place to be is in the middle, where depending on your mood and the problem and the drive, etc., on that time, you can just shift between which side of the spectrum you want to be.
Barbara, anything to add there?
Yeah, no, I think Natesh did an amazing job. I guess I'll add two quick things. One thing I like about Gladstone is that it's sort of, it doesn't, I can't spin up, can't build a PRS in 2 minutes like I could at Genomics PLC, but it does sort of fill the niche of having a very targeted directive at the end of the day, right? Which is cure disease. And again, broadly writ, cure disease is very vague, but when you talk to specific people, there are specific diseases and specific mechanisms that those cures happen through, and they need, statistical help. So that's that fills that thing. Another thing I'll say that I love about academia, and that I don't feel like I could do in industry. So right after I got tenure, that's a moment where you sort of sit back and think about what you want to do with your life. And I was attending this meeting, this NIH AI working group or whatever, and people were shouting loudly about the role of, Google and Verily and these other things in machine learning and at the NIH. But ultimately, Redia Abebe said something that actually I would argue changed the course of my research, which was, we talk a lot about disparities in health, and the problem is not that we're not fixing them, it's that we don't even know how to measure them. All the papers that you read are qualitative, right? All the papers that you read don't actually use statistics to measure these disparities. So very quietly, if you actually look at my work from like 2017 or so, it's entirely focused on building the methods and starting to deploy the methods that can actually start understanding disparities in health, because she drastically affected me. And you wouldn't see it. I mean, I haven't actually published any real papers on disparities in health yet, but I have published a whole bunch of contrastive methods that, we're now applying to these problems. And I have published a whole bunch of, or the multi-group Gaussian processes, which are going to be able to allow us to, split on categorical variables in the posterior of Gaussian process regression, and these tools that hadn't existed, that I felt would be able to allow us to do this thing, and also, getting access to more data, getting access to more collaborators that were interested in these ideas. I feel like it's all been building to this point. All to say that, this is a 7-year path for me and my research, and that's not something you can do in industry.
Well, this is great. This is a great lead-in, because Yang Gong just asked, how different / similar are academic versus industry, like research-based questions? I know this changes depending on what sector, I guess, of industry you're in, but yeah, if you can give everyone
a. Maybe I can go first, and next time Barbara can go. It is very similar, at least for me, surprisingly similar. Or maybe I'll put it this way: being involved in industry really has changed both my taste for the problems that I choose to work on, and I mean, again, not every problem has to be of very applied and interest to a large group, but at least most of it is. And also, even the theoretical questions of what I want to know about something, what I cared about earlier in my earlier parts of my career versus what I care about now, even if I'm interested in something quantitative, is very different. And so it doesn't, at least in my experience, it doesn't have to be these two problems, or the set of problems that one works on doesn't have to be vastly different. Or at least I'm making an effort to have similarity in both.
Yeah, that's amazing. I'm actually kind of jealous. I feel like Amazon's a fun place. Yeah, I have felt really I think differently, in the sense that, at Genomics PLC, again, I got to work on really cool polygenic risk scores in a way that you can't in the US, right? Polygenic risk scores are a different thing here because we don't have socialized medicine. Similarly, 23andMe, like I got access to the craziest stuff, and, wanted to, I mean, the first question to ask is perhaps like, can we, look at admixture? Can we do chromosome painting, figure out ancestries of all of these genomes that we have? So the questions that I wanted to ask were not the questions that I think necessarily were the ones that, the company wanted to answer. Even if I ultimately could explain why it would affect, the bottom line, the product, whatever it was. Maybe it was because they were startups, they were smaller at the time, and it was harder to make the case. I guess one thing that I mean, the commonality in 23andMe and Genomics PLC is, again, they were small groups. So I was tasked to do a particular thing. And if I diverted from that, then, there was no one to fill in that role because there's 12 of us or whatever. Right. So I needed to do a job. And if I didn't do that job, and if I got diverted and did what I wanted to do, then sort of all hell would break loose and I wouldn't be doing my job. So maybe it had to do with the size of the companies. Yeah. But I definitely felt like I had to do a thing. Yeah.
We got a really great question I just loved right now. How do we encourage our underrepresented students to pursue academia over industry, given that they might think industry pays more and looks better on their resume?
Do you want me to take that one first? You can go too. Okay. All right. Well, so this is a really good question. So yeah, I mean, it really depends on your value system. Some people just need to live with a better salary. That said, as soon as you get, you have better healthcare, better support in a lot of ways, right? In industry, and there's no no problem with that at all. Like, I totally respect that. That said, you know, as soon as you're most academic, oh, now my light went off. Most academic places allow you to do 20% consulting. And depending on how you do that, or, you know, you could do a startup, or you could do what Natesh did, or a lot of people do Google the Amazon Scholars right now, which is really exciting and pays a lot of money. So there are ways to do sort of have your side gig while you're in academia. So if money is the issue, then think about, you know, struggling up to the point where you can do that. And get these profitable side gigs. But really, I mean, Natesh said it earlier, and I am shocked I haven't said it yet, but the reason I think I'm here, and the reason I think a lot of us stay in academia, is because of the students. And, you know, really working with 20-something-year-old students every day is why I wake up in the morning, right? It's not necessarily my research vision. What my research vision is separate. I wake up because I get to work with some of the most brilliant and enthusiastic scholars in the world. And, you know, we write on whiteboards together, and that's like totally thrilling. And you, whoever we're talking about, as someone from a marginalized community, is going to have a huge impact on a generation of students by just standing up at that whiteboard and working with them. And it's hard to explain that, but that is literally the one and the most fulfilling part of my job, at least. And that's why I do it. It's not for publications, honestly.
I plus one. I'll add a slightly different point, that the easiest way to keep people in academia, especially if they want to do industry, is to take away the stigma of working in the industry and make it welcome for them to go work in the industry and come back. And just remind them that there is always a security safety net at home that welcomes you back. So go back and do what you want and come back and teach it to our students. And in fact, give them credit for doing that. I also believe that my prediction is that, especially at least in the tech area, I don't know about others, in statistics, ML, CS, and all of the bios, and anywhere that technology has an influence, it's going to be increasingly hard for academia to just keep faculty sort of hold up. And it's also not very productive. Instead, just let them go fly and find out an arrangement that works for both parties, so that they still have some commitment of most of the commitment towards their academic institution, and yet they are valued for their industry work. And that could be sabbaticals, that could be 20% commitment, the summers, you know, so many opportunities these days, and it should be the norm. And then the problem will work out itself.
Yeah, I have many thoughts on that, but I want to maybe touch on this next question, which is someone asked, what would you suggest to those who are still exploring between industry and academia? But before you answer that, I kind of want to split that up between like maybe two populations of people, because I get this question a lot from students, and I think there might be strategies that one might think when you're a student that may not apply maybe when you're a faculty member or maybe a senior professional. And so do you have suggestions for maybe both groups of people on, you know, how to explore between both industries, how you personally balance your effort between both sides, and maybe some strategies, tips, or challenges that you faced in navigating this kind of unique space that you both carved out for yourselves?
Yeah, I can go first this time. I would say the first is networks. I think that's universal in knowing people who you trust and respect, and who have your best interest, who are also in the industry, and there are quite a lot. Make sure to talk to them, and this is true for both population. And secondly, in choosing which industry to take, use it based on your interests, and really do the due diligence, I think, in understanding what your role would be in an industry collaboration. And it's often easy to not have, you know, often people will be happy to explain what the experience would be, what you would be working on, and how you can add value, how much time it takes to ramp up, and all of that. It takes it pays to really do that work before you get into a commitment. So I would say.
I mean, I echo all of that. I think, yeah, doing due diligence is absolutely essential. Understanding whether, whoever you're going to be working with and for at Apple or Amazon or 23andMe or whatever is sort of has aligned values with yours is a really big deal if you're going to be spending time there. But also, as at least I've done, take opportunities every time you have. If you have a sabbatical, try it in industry, right? If you have a summer internship, possibility, definitely take advantage of that. I mean, I think I'm pretty sure I encourage every single one of my students, PhD students at some point to go do at least one job in industry. And the sad news is like, that's actually banking in particular has lured like 3 of the people that I could have sworn were going to be professors. And, it's great. I'm really happy for them. They're making buckets full of money right now, but it is sometimes hard to see that, but it's also great for them. I mean, they're extremely happy and it's a wonderful place for them. So I just say try everything, take all the opportunities, whether you're a student or a professor. Yeah.
I have a follow-up question there, which is my own, which is, what are your advices for people who are maybe professors who want to think about how to add this to their daily lives, like have a industry part of their job, and kind of have one foot in, one foot out? What are some like negotiation tactics? And some people just don't know how to even get started here, of how to even have these conversations on how to explore. So what are some things that you've done, whether with mentors or colleagues outside of the space, but also like within your institutions to kind of broach these topics? Like, do you have advice there?
You want to go first, Barbara, or I'm happy
Sure,
to take?
I can go first. I'll say, I mean, a lot of institutions right now are really excited about sort of incubator spaces and building startups and things like that. I'm not really going to do that. I think it's probably too much emotional energy for me to deal with, but that's definitely an option for you. And I have students and postdocs that are really eager to start their own companies, which I think is great. So take advantage of whatever resources exist at your university to do that, if that's something that sounds interesting to you, or a student or a postdoc. If you have help, someone to actually do the hard work, while you sort of get to sit back and advise, that's probably also fun, could be fun. So there are definitely resources there. Like I said, there's usually in your contract a 20% clause. I didn't take advantage of this 20% consulting time. So it's like 1 day a week of consulting that you're allowed to do, usually at universities. Yeah, post tenure, I started taking advantage of that in sort of roundabout ways. People would ask about, oh, could I just, get on a call once a week to talk with someone at their company about, machine learning, or could I be in a scientific advisory board where they either know how to manage my expertise or they have no idea, or, things like this. And these will start coming up as you become more and more senior. But there are also, companies like Amazon, like Apple, like Genentech, that have really opened doors for starting consulting and projects together. And maybe it would start out as, a project that you do together with some data. 23andMe does this too, but eventually end up as a consultancy. So that's one way maybe to test the waters also and do due diligence, is to actually do a project with Apple or whoever it is, because they're very open to doing stuff like that usually. Yeah.
Yeah.
Can I say one more thing really quickly? I'm sorry, this is part of the question, and I realize that this is something I have big thoughts about. So you're going to see your colleagues do this a lot, and as a woman, I'll say like 90% of my male colleagues on paternity breaks went off and started a company, which was absolutely devastating because I had maternity leave and all I was doing was just like feeling sorry for myself and recovering. And that's me being a little bit bitter, I know, but if you have an opportunity to take time off and do what you need to do, take it, first of all. That's all. But I'll say that some institutions handle, I think, the people who are more academics that are more industry focused better than others. So Princeton, I would say, did a terrible job of this. They were trying to sort of mimic, I think, what Stanford does, which I think they do a really good job. And they sort of fell flat. So I had a bunch of colleagues that were 50%, you know, some other company and 50% Princeton, but they ended up not doing service. They ended up not teaching classes, putting an inordinate amount of burden on those of us who were 100% and didn't have those industry ties. So it was really hard being an untenured machine learning person there, when every other person who could possibly teach a machine learning class was not able to do the service or the teaching that had to be done, right? So that was, I felt like that was a bad system, but Stanford seems to be the opposite. It really basically lets junior faculty in particular do whatever they need to, and there are very firm requirements for even the senior faculty people who are doing industry in terms of teaching and service loads. Yeah.
Yeah, it's interesting to hear about the paternity leave thing. It's striking.
Yeah, seriously.
I would just add to what Barbara said. The only thing would be that often the recruiters in many of these companies are extremely knowledgeable and have done this before in helping people transition from academia to industry, use that opportunity to help to talk with them, to explore different teams because it's not, you know about your work and what you bring to the table more than they would know, and being able to know what problems are there. Once you start talking to them, perhaps after signing an NDA, which is, I think, relatively easy to do, you'd get much more exposure to the problems, and then you have a much more informed view of. You get to choose your problems, what you want to work on.
So I'm gonna try to combine these next two questions so we kind of stay on time, so I don't get in trouble. So a lot of times we're learning in academia, I think you guys both touched on this a little bit, can sometimes seem a little far removed from what someone might be practicing in industry. What are some practical examples that you both use in your day-to-day lives to kind of bridge those two worlds? And the second question I'll ask, I think it's a little bit related, which is, while you're doing this, a lot of times there might be ethics might be different in those two spaces. I would like to believe that they're not, but sometimes there are. It's just basically reality. So how do you also uphold your own personal ethics and balance your ethics in both spaces while trying to bridge those two worlds?
What does ethics here mean?
I don't. They said moral slash ethics. You have your own morals, maybe things that you're particularly willing to work on, or maybe ways that you're willing to go about things that may not be conducive to the environment of maybe fast-paced industry. How do you think about those challenges?
I mean, I think the latter question is easier to answer. I mean, at least fortunately, I've never encountered a situation where the people I worked with in forced me to work on anything that will question the moral value. So fortunately, knock on wood. But the former question, I think, is, I try to be a student in and constantly read whenever I can, and also do hands-on work, implement. And academia, there's quite a lot of good work happening. Some of them just really do not work, and the academics really don't care because it's an interesting idea to move the field forward, but not necessarily scalable and due to infrastructure challenges, etc. But yet still reading those still continue to inspire me in really thinking about taking that idea and making it work in a very hacky way. So there's huge benefit to being aware, even if you're working in industry, there is huge benefit, in my view, to look at what the literature is, what are people saying, at least in your subfield. Of course, AI is AI is a field where you have to up-level yourself every 2 minutes now. So that's a challenge that I haven't quite figured out how to manage. And it's impossible to even hope to be knowledgeable about everything. But within your subfield, I think it's really manageable, and I think it's even worth doing.
Yeah, I agree. I mean, there's a lot to say about both of these questions, I think, together and separately. But I'll say I sort of alluded to it before, but one of the, after I came back from thinking about polygenic risk scores for a year at Genomics PLC, it was amazing. I mean, there's really the potential there to screen millions of patients and possibly catch, cancers or autoimmune diseases or whatever, these horrible things are before they manifest in big ways and are untreatable at that point. So that was really exciting. So I came back to the US and started asking around with all my, big hospital collaborators. And one hospital administrator just said straight up, we make money off of sick people. And we're not going to use polygenic risk scores. So that was a shock to me because I mean, it's true, but I think ultimately, if you're in industry, whether it's a hospital industry or a startup, you make, I mean, the goal is to make money, right? You're indebted to your shareholders and everyone else, and you have to kind of toe that line always. But that said, I mean, there's also huge issues with ethics in machine learning, like full stop, right? I had the opportunity to teach a machine learning for social justice course at Princeton, which was lovely. And I'm hoping to actually recreate it at Stanford here for undergrads. But we read Ruha Benjamin's book and about design and specifically, bias in design. And that really affected me thinking about all of not just using bias data, so like the recidivism rates from these COPSS scores in Florida. We looked at this data and calibrated it, and it's absolutely true that the Black parolees in this study were way more likely to be arrested again than the white parolees. And as Ruha Benjamin says, you cannot stop there. And that's first order racism, right? You have to look at the second order racism. So we looked at why they were getting arrested again. And it turns out it was for traffic stops, way more than the white parolees. And that's where you hit the wall of like, why are we building these scores that just continue in this echo chamber of unethical social behavior? It's just, sometimes it gets really frustrating in the name of statistics to build models that just propagate the same behavior,
Yeah. That's my very last question, because I think we spent a lot of time, first of all, I love those both answers. We spent a lot of time talking about academia to industry. As a last piece of advice for everyone right before we close, do you have any advice for someone in industry who wants to get into academia collaborations and wants to explore more opportunities? How would you go about that? Or how would you advise going about that?
I can take a step. I think it's earlier. If my impression was that people used to say academia to industry transition is easier than the other way, but I think that both transitions are very easy these days, and whether it's being from a full-time industry researcher to being an academic position in a tenure track, or being an affiliate or an adjunct, or even just striking up a collaboration with an academic. Academics love to hear from other people with a problem, especially if the problem is really well formulated, and then say why usual methods really do not work on some groundwork. That's just like music to academics' ears, right? So, and that's always there. And often, in my view, companies are, as long as it's not sensitive and it doesn't give away either the IP at the initial stages, at least, companies will let you do an NDA to do a collaboration. And we are currently doing one at LinkedIn. By the way, maybe I'll just add one more point to Barbara's excellent answer last time. So the part of my job, and the reason I took this job at LinkedIn, is specifically to really take a hard look at the scores from AI models to see if we have different treatment for, or do we give equal treatment to our members? And that's why it's a truly challenging problem. And we are approaching it from a very humble place, that the problem is hard. We'll try to do what we can to be ready and to measure and mitigate. And this is where I started that. And this is particularly, I see this as an opportunity because while academics have worked quite a lot on this, this problem is not in the radar of many industry people, but it will be. And so academics can really help a lot there.
Yeah, I agree with everything you've said. I think we an academic love a well-formed problem. We also love data. I'll tell you what we are challenged with is if you sort of throw a underpowered data set on our desk and tell us to solve it. I think coming to us with the question and, you know, experimental, like good experimental design and a whole bunch of other things, like that would be amazing. I would be over the moon to be talking to someone from industry with a huge amount of data and quality experimental design. So yeah, I agree. We'd be really excited. And the other way, I mean, a lot of companies have ways that you as academics can reach out to them too. I mean, whether it's pharmaceutical company with a whole bunch of tumor data in response to a particular drug, or you know, Regeneron has these ways you can apply to be an academic researcher, or Amazon or Apple, or, you know, you name it. You can kind of start working with huge data sets and really amazing people. Yeah.
Well, I think we're about to wrap up. I just want to thank everyone for listening. If you found this conversation useful, like, please share the recording with your colleagues and friends. I want to say a special thank you to everyone behind the scenes: Megan Glenn, Mary Ryan, Natalie Dean, Amina Manatunga, and Jim Rosenberg. And a special thank you to both Barbara and Natesh for hanging out. You guys both know that I think you're rock stars, but this conversation was super fun. So I'm glad we got to do it. And yeah, please everyone stay tuned for more events like this from both COPSS and NISS leadership webinar series. Thanks everyone for hanging out this afternoon. I had a really good time, and thanks everyone for having me.
Thank you both.
Amazing job, Lorin. Yeah.